Hello everyone, welcome to class 15 of CM1. I'm Pratap from Smears Education Solutions. I'll discuss level annuities, the proof of level annuities today in the class, and this will be class 5 of annuities, the basic annuities. We've already come across the 5 kind of annuities, 4 kind of annuities. The basic annuities we say, and we'll see the proof of the formulas in today's class. So let's do one by one. This is time 0, then time 1, time 2, time 3, time n minus 1, time n. These are the periods. 0, you can write 1 here, then 2, 3, n minus 1, n. So 1 here, 1 here, 1 here, 1 here, 1 here. If you count all total, these are n payments. You have to find the present value of all these. This is here, and this one will come here, this one will come here. That way you have to find the present value of all. So I'm not making it clumsy. This is V. The present value of this is V square. We already know. And the present value of last one is V power n. Because we want to find the sum of present value of all the payments, 1, 1, like this, we'll add everything here. Present value of this one, that is V, this one, that is V square, this one, that is V power 3, this one V power n minus 1, this one V power n. This is what we want. So finally we add everything. This is nothing but an. So let me find an here. It's so simple now. Remember, while doing problems, never use this way, at least when you are using directly annuity. We can take V common. You will get this one. This is a geometric series. Remember this formula. This is very, very important, though easy. We'll use 100 times in CM1. And then 1 minus Vn. This V you bring here. That is I. You can check it. 1 minus V upon V will be equal to I. You put 1 upon 1 plus I in V, you will get this one. This is the proof. It's very easy. An is equal to this. We've already used this formula. This is not a new one. However, if you know the proof, you will feel better. That's why you should know the proof of the formulas. Now, this is 1 point. This is 1 point. This is 1 point. This is 1 point. This is n minus 1 and then n. Same points we have. Now the payments are here. One is here, one is here, one is here, one here, one at n minus 1. We don't have any payment at n because this one is for the future year. We have to find the present value here. So this one, then present value, then this way, then finally this you have to find here. So what will happen? This one, the last one will come here. The notation is an due. We should never forget the notation. Here the notation is an, though I've written already here. Now an will be equal to due 1. It will start with 1. Then the present value of this one will be v. We'll write here the present value of this one will be v power n minus 1. Again geometric progression, like here we'll directly get this one. That's all. 1 minus v is d. We've already used this formula. This is the second one. An due. Now let's go to the other two. Sn and Sn due. This is the first one. Second one, you can say n minus 1 and n. 0, 1, 2, n minus 1 and then n. The payments are here. These are the arrear payments. So it will come here. So our notation will be Sn here because the payments are in arrears. And then we need to find the future value. So this one will come here. This one value here will find. This one value here will find. This one value here will find. This one value. This will be 1 anyway. Will not worry. So if I write it here, Sn will be equal to, I can start from this side now, 1 here. In the second one, this one future value 1 plus I. This one future value 1 plus I square. This one future value, this one future value here. So the last one, if you see, that will be 1 plus I power n minus 1. You count here from 1 to n, so n minus 1. Again, simple geometric progression formula. That will be equal to 1 minus, here you can take r if you want. Let me write the geometric progression formula for you so that you can remember all the time. This is geometric progression. I've taken r for 1 plus I. If you get up to rn minus 1, suppose you get up to 5, you have to write 6 here. This is the formula. So you have to apply simple formula, that's all. 1 minus 1 plus I power 6 divided by 1 minus 1 plus I. And then here if you cancel 1, you get I. And you change the side because you get minus I here. I will write 1 plus I power 6 minus 1 divided by I. That's all. This is the third one. And then we'll go to the fourth one. This is the last one. The payments are due. So let me write the due payments. This is 1, this is 1, this is 1. I have to write due payments here. So 1 for the coming year, 1 for the coming year, 1 for the coming year, and here 1. No payment is here. Now we have to find the value here, and this will be Sn due. This will be Sn due. here SN due. So now let me write the points also here to avoid any kind of confusion later. This is 0, this is 1, this is 2, n minus 1, n. So what you need to do is you have to find the future value, the accumulated value of series of payments, and these are the due payments. Payments are at the beginning. You have to find here this value here. There is no immediate value. This value here, this value here, this value here, and this value here. So these are the ones you need to find. This value, once again, let me draw. This value you want here. So the value of 1, if you see, it will pass through all the years, n years. And this will pass 1 year. So instead of 1, this one will get 1 plus I. This future value, this will sit for 1 year. This money will sit in the bank for 1 year. This money for 2 years. This money for 3 years. This money for the whole n year. So here you just multiply. If I write SN due here, the expression, it will start with 1 plus I, unlike 1, and it will end at 1 plus I power n. That is the only difference between the previous one and this one. So to evaluate this expression, we need just one line, not more than that. Let me write here SN due. I'll take 1 plus I common, then I will get exactly this expression, and I can write this one. So 1 plus I, 1 plus I, then I can use this one. Then you bring this 1 plus I down, I by 1 plus I, that is D. This is what we wanted to prove here. So somehow while writing, it becomes 6. Okay, let me change it to n. So this is also the formula for this one, Sn. This is for Sn due. These are the two formulas. These are accumulated values and these are present values. That's all for today's class. If you have any doubt, you can always comment below and ask. We'll answer. If you enjoyed, please like and share the video. Subscribe to our channel to keep up our latest contents. Thank you.